Welcome to. We have interference fringes are observed on a screen by illuminating two thin slits 1 mm apart with a light source. It is lambda is equal to 6328 nanometers. The distance between the screen and the slits is 100 centimeter. If a bright fringe is observed on screen at a distance of 1.27 millimeters from the central bright fringe, then the path difference between the waves which are reaching this point from the slits is close to, and we have to choose from the four options. Let's move to the solution. The solution is given d is equal to 1 mm, that is the distance between the slits is 1 millimeters apart, and lambda is equal to 632.8 nanometers, capital D is equal to 100 centimeter, and y is equal to 1.27 millimeters. So delta x is equal to d sine theta. Since theta is small, we have delta x is equal to d tan theta. Delta x is equal to dy upon capital D, that is equal to 1 into 10 to the power minus 3 into 1.27 into 10 to the power minus 3 upon 100 into 10 to the power minus 2. That leaves us with 1.27 into 10 to the power minus 6 meters, or 1.27 micrometers.